officially live. Okay.
Wait, Gary.
So wait, it's officially live. So we are going to talk about conjunctions today.
Conjunction, what's a function?
In
I thought that was a word thing. I know, me too.
it is. It is. What does it mean in words?
Conjunction,
And, but, or something, whatever.
It's words that connect two phrases.
Words that connect two phrases together. That is exactly what we're going to be
Oh,
doing.
do they connect terms together?
In this case, we are going to be doing words that connect inequalities together.
Oh.
So for example, let's say I had, and actually the two words in math that they use are and
or.
and or.
Oh, I was right.
Right. And the one we are going to focus on today is and. Okay? And so now in the past, we'll just kind of review inequalities for a second. So let's say I said x is greater than or equal to -5. So I would draw a line, and I'd go, here's 0, here's 1, 2, 3, 4, 5, that's -5. Welcome, you guys.
And you'd have the open circle.
So yeah, now is it an open circle or is it a solid circle?
No, it's a solid.
It's a solid, like it equals that point. So you got to make it solid. It's only open, and I noticed on the homework a bunch of you still have confusion about this. If it says greater than or equal to, it's solid, right? It equals that. Doggone it, I got to color it in, right? It equals -5. It's also greater, greater than -5. Which way is that? I notice also a lot of people on the homeworks are going the wrong way.
It's pointing that way.
X, right, this says x is everything that's bigger than or equal to -5. Where's bigger? Bigger on a number line is always to the right, right? So your arrow is going to go this way, right? And it goes on forever. Yes, Hunter?
Like, what I noticed, I used to have a lot of trouble with that when I'm writing the number lines and stuff and the greater and less than symbol. The back of the greater and less than symbol is sort of like an arrow, and it's pointing to which way the line would go.
Yeah, that's what I was saying.
Yeah, that's what I was.
That is really good. Hunter, thank you for sharing that.
Because it's like the arrow.
Did you guys hear this?
Yeah, well, it's like the greater than is like an arrow.
Right, exactly. So look at that. That's an arrow. That is an arrow. It's telling you going that way.
Yeah.
Right? It only works if the x comes first. If I wrote it the other way, -5, if I said -5 is less than or equal to x, that's the same thing. Those are identical. Because notice the x has a great big mouth facing it, and the -5 has the tiny point. Here's the x, it has the great big mouth facing it, and the tiny point is facing the -5. Those say exactly the same thing. But if you wrote it with -5 first, it's not going to show you the correct direction of the arrow. But as long as you have your x or your variable first, then it will always show you the direction that you're supposed to put the arrow. See what I'm saying? So as long as you write it like that, then you will always know which direction to shape or to put your arrow. Not to shape, but. All right, so that's pretty straightforward, right? Now, what if I said this though?
X is.
Now, let me get rid of all this mess that I've made. I'm just going to start over. Let's do it differently. Let's say x is greater than -2, and I said and x is less than greater than -2, and x is less than 4. Right? So let's think about this for a second. Our two endpoints. What are our two endpoints?
-2 and +1.
Right, so we got a 0 here, we got -1, -2, and we got 4. We got to go over here. 1, 2, 3, 4. That's 4. Now, do I do solid circles or open circles? Why? Do I do a solid circle or open circle? Yeah, that's why I called on you, because I need you to focus. Oh, you were? Okay, sorry. So, but seriously, we've got these. Look at these. We've got x is greater than -2 and x is less than 4. Will it be an open circle at -2 or a solid circle? Solid would mean it's equal to. right? Open circle, it's not equal to. It's always bigger than -2. It's not equal to it, so I can't touch -2. I've got to go around -2, right? It's going to be an open circle. What about here? X, how about Sakara? X is less than 4. Is it an open circle or a solid circle?
Open.
It's an open circle. It's got to be, exactly. It doesn't touch 4. Now, X is always greater than -2. So look, if X is first, it says I got to push the arrow that way, right? So I'm going to go this way, and I know it's going to go that way. Let's check this one. X is less than 4. It's got to go this way. So my answer is right there.
So you have to like put an arrow going like back.
You don't need an arrow.
Oh,
Because the arrow represents
infinite line.
infinite line. And though, yes, that is an infinite line, but because I'm saying and,
So it's
they both have to be true.
So it's like a
Here, X is greater than -2, but it's not less than 4. So therefore, it's not a solution here, right? Here, X is definitely less than 4, but it's not greater than -2, so it's not a solution. In order, when you use the word and, both of them have to be true in the solution set. So the solution set is from here to here. That's it. Does that make sense? Now, that is not the way you'll usually see them with the word and. Well, that is one way you'll see them. Actually, I'll say that. But a typical way you'll see them is this. Instead of writing it like this, they'll put the X in the middle, and they'll do X is greater than -2 and less than 4. That's how you'll see it. You have X in the middle. So write that down in your notes because that's important. When you see that, you have to read it.
That looks confusing.
It does. But read it from the center. You start from the center. Don't go from left to right. Don't say -2 is less than X, which is less than 4. Don't do that. You'll totally get lost. Start from the X, and you're going to read it backwards. You're going to start from the X, and you're going to go this way. Is X? That means X is bigger than, right? Because the big mouth is facing the X. X is bigger than -2. Okay? So you plot your -2, and you go bigger than. X is littler than 4. Plot your 4, you go littler than. See what I'm saying? So let's try a few. Can people see? I guess so.
We should do whiteboards.
Let's try a few up here first because it's still the lecture. Can I erase that?
Yeah.
Yes? Let's try another one. But this time, let's write it like this. Let's say X is greater than 7 and less than 14. So I've got my line. Here's 0. Here's 7. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so what do I do? So when they are written in this format, you immediately know your two endpoints. 7 on the left, 14 on your right. It's always going to be written like this where almost, well, I've never seen it, where they write this bigger number on the left. It's always the smaller numbers on the left, bigger numbers always on the right. Doesn't mean you can't do it the other way, but pretty much that's the way I've always seen it, yeah. Makes sense. I mean, you might as well, mathematics is about doing things logically and simply.
An open circle on 7.
Okay.
No, a closed circle on 7.
Closed circle on 7.
And then an open circle on the 14.
Open circle on 14.
And then you draw the arrow.
And the line goes in between, right? Right. So there you go. Piece of cake. Let's try another one. I'm going to write it out the whole way now. So X is less than or equal to 50, and 2 is greater than 4,000. Okay, so here's our line. And we're not going to go one by one by one by one, right? So we're going to say this is 50, and we're going to say this is 4,000. Okay? Why not? Right? And now what? So help me. Amika, help me. I want to graph it.
Okay, so the x is, so you do a dot on the 50.
Okay, solid dot.
And then a line.
So it's going to go which way? This way or this way?
Wouldn't it go less, like to the left? Well, because...
Oh, wait a minute. Yeah. Wait a minute.
You're at it. That's not possible. Well, it is, but it'd be like...
All right, so let's graph it for a second. Let's graph it for a second. So what is it? X. This is not what I meant to do, but this is good because this is actually, this would be the next step. This is not what I meant to do, but I did it. So let's go with it. We'll see what we do. So which way would I go? I'd go this way, right? Okay, look. All right, so it goes that direction. Now what would I do for this one?
X is greater than 4,000, so that would go to the right.
Well, that would go to the right.
How does that make any sense?
But that's not possible. X can't do both of those things at the same time.
So and means that they both have to be true in order to be a solution. Are they both true here?
No.
Are they both true here?
No.
Are they both true here?
No.
Are they both true here? There is no solution. No solution. Because there is no place on that line where they both are true. And means they both have to be true. Does that make sense? You get that? Now that's not in the chapter, I don't think. I don't think they covered that. But you graph exactly what it says and then you do it. Now let's do it differently. I didn't mean to do that one, so let's try this. X is greater than or equal to 25, and X is less than or equal to 110. So here's 25, here's 110. Hunter, help me.
Alright, so you would put a solid dot on 25.
Okay.
And then a line going to the right.
Okay.
And then you would put a solid dot on 110.
Okay.
And then go to the left. The line to the left.
So I just make a nice big thick line and I'm done. Now write it in the other format now for me. Hunter.
It would be...
It's really easy, guys, in this format. Once you've graphed it, to write in this format, because you have your two endpoints. Go ahead.
So it's X in the center.
Right?
Then on the left is a less than or equal to symbol.
Yeah.
Wait, what?
Yes?
Yeah. And
Right.
then,
Well, X is greater. Yes.
Yes.
That is a less than. Except you're reading it this way. But you're right. Yeah. Go ahead.
And then you put a 25 there.
Okay.
And on the other side, you put a base going that way.
Yeah.
Yeah. And then you put a 110.
You got it. See how easy it is? Once you've graphed it, the X goes in the middle, this goes here, and you just make sure, you can just look at your dot. Oh, it's greater than or equal to, right? X is greater than or equal to 25. X is less than or equal to 110, less than or equal to 110. Really easy to graph them. So that is conjunctions. When I teach this, usually I go into much more detail, but that seems to be kind of where they've gone, and so I don't want to overdo it. But this is an example of one that you're likely to see eventually. I don't know when Saxon will get around to it, but you will eventually see something where it's impossible. There are no, basically, let me just clarify. In order for them to both be true, they actually overlap each other. Does that make sense? They're running into each other, right? This one, if I came up here, this one's going this way, right? And this one is going this way. And right here is where they overlap. All of this overlap That way you know they're both true, because they both are overlapping. It's when you don't have any overlap. There's no overlap. This will never overlap this. And if it's an and conjunction, then there's no solution. If it's an or conjunction, there is a solution. This will be just a precursor. If I said or, let's say I changed that to or. Let's say I said or.
That's correct.
Now it is correct. Now it's not no solution. If I get rid of the and change it to or, suddenly, what is my solution? It's either x is less than 50, or x is less than or equal to 50, or x is greater than 4,000. And your answer would be that. You'd actually rewrite that as your answer. You know? Anyways, those are called conjunctions. You often use conjunctions with inequalities in math. And so that is it. And we're done. Questions?